lesson we're going to learn about simultaneous equations, but the type that we're going to learn about is graphically, all right? So we're going to learn 3 different types. Today we're only going to learn one, but there's 3 different ways of solving simultaneous equations, all right? So let's make sure that we use our learning goal, and off we go. Okay, so solving simultaneous equations graphically is about looking at a graph and solving it. Now, this is the x-intercept, the x-axis of a Cartesian plane, all right? And this is the y-axis, all right? So one point, say this point here, it looks like that's 6, that's 7, that'll be 4, that'll be 3, 2, 1. This will be 1, 2, 3, 4. So if I look at this point, it has an x value. So we crawl to the x value, and it looks like it's 7. And it also has a y value, and we climb up to the y value, and it's 4. All right. So just to reiterate what we've just done, this is the x value, and this is the y value. Okay. So simultaneous equations have both an x answer and a y answer, just like a point does. I'm just going to get rid of the highlighter here, okay, and we'll get on to the next one. So to solve simultaneous equations graphically, we have 2 lines here, all right? We have the red one, which is this one. We have the blue one, which is this one. And this is our equation for the blue line, and this is our equation for the red line. To solve them simultaneously graphically, all we have to do is look at their point of intersection, which is here, okay? So what I'll do is I'll crawl to where it stops. Oh, that's 1, so that's going to be 1. And I'll climb to where it belongs, and it also is 4, so this is 4. So the point of intersection is 4, so I'm going to write that in. Point of intersection is 1, 4. Therefore, x equals 1 and y equals 4. And why? Because the first one always refers to the x value, and the second one always refers to the y value. Okay? Let's do the next one a bit quicker. So to solve between these 2 lines, and we've got their equations over here, this is the point of intersection right there, and it looks like it happens at 2. So we'll put 2 first, and we have to climb up to 6, 7, 8. Looks like it's 8. So therefore, point of intersection is 2, 8. Therefore, x equals 2 and y equals 8, because that's x and that's y. All right, with this next one, we actually have to draw the lines. In the previous one, it was pretty straightforward because the lines were drawn already. In this one, we have to draw them. So we have to do a table of values. So I'm going to start my table of values at -3. Oh, I'm going to use a different colour. -3, -2, -1, 0, 1, 2, 3. Remember, with table of values, we pick the numbers of x, and then we find out what y is, okay? So there's going to be 2 y's, so I'm going to have to put another line here, because it's going to be for both of these things, but I'll explain that really soon. So let's look at this, okay? When x equals -3, so I'm going to go y equals -3, and then there's still a +1, so what I'm doing is that, see this x, now it's minus 3, and I substitute it in, but there's still that plus 1, so I've got to put plus 1. What does y equal? Well, y equals, what's minus 3 plus 1? Minus 2. So what I'm doing is I'm putting everything into this machine, okay? These are my values of x, so I'm going to substitute them into the problem again. So let's do this one. Instead of minus 3, I'm going to put minus 2, because that's the next number along. So I'll go y minus 2 plus 1, that's minus 1. And instead of minus 2, I'm going to put minus 1. So I'm going to put minus 1 plus 1, that's just 0. And I can see a pattern that's emerging here. This is going down by, it's going up by 1 plus, it's going plus 1, plus 1. So that's really good. So I'm going to take a stab in the dark and keep going with it. So it's going to be 1, 2, 3. What I'll do is I'll just check by doing the last one. So instead of, the last one's 3, so instead of those numbers I'm going to put 3, it's still plus 1, so I'm going to go plus 1, that's 4. And it actually goes up by 1 as well. So that's that done already. Now the next one, I have to do a little trick that I need to do. I'm going to rub everything else that I've been using out from this one. I want to make it y equals. So this 3x is stopping y to be equal. So I'm going to minus 3x there. And that means I'm going to minus 3x over here. So I'm left with y equals 9 minus 3. And I'm going to put times and a big bracket here. X, because remember there's a times in between the 3 and the x always, so that's why I have this times here. Now what's my first x value? It's minus 3, so from here, so if I do this calculator, I can put this in my calculator straight as it is, just make sure that that's a times, it's not an x, okay? So 9 minus, and then we've got 3 times negative 3, which is minus 9. So we're actually adding them. So minus 9 plus 9 is 18. So that's, we'll go y. The next one, we'll put minus 2, because that's that number there. So we'll go 9, and the double negative, make sure you pop it in your calculator. I'll show you what's happening. I'm going to bring it down here. We've got 9 minus 3 minus 3 times minus 2 is plus 6, so we're going to be left with 15, and then we change it to a 1 because that's negative 1, and it'll be 9 plus 3 in this case, so it will be 12, and I'm going to fix some of this up. And we're actually seeing a pattern emerge here as well. It's going down by 3. Now there should always be a pattern that emerges. So I'm going to keep this pattern going because it's easier than popping it into the calculator, I think. But you can put it in a calculator. So that'll be 9 minus 3, 6, 3, 0. Okay? So what I have to do now is I have to plot this on the graph. So what we have is that at minus 3, so at x equals minus 3, so at x equals minus 3, so that's here, all right? So I'm going to put a value, I'm going to put this point in minus 3, minus 2, which is minus 3, minus 2, looks like it will be here. That minus 2 belongs to there. But also the other one is 18, so at minus 3 I have to go to 18, so it goes way beyond here, so I'm not going to write it in. So at minus 2, so I'm looking here now, it says it's minus 1, so that'll be here, okay? And the 15 here will go way beyond that axis as well, so I'm not going to put that in. At minus 1, so we're looking at minus 1, that's here, it goes to 0, So 0 will just be here, okay? Y equals 0 will just be there. And 12, we can almost put that in. I'm going to put it in a different colour. Minus 1, it will look like it'll be around here. So I'm going to put that dot up there. All right, next one. At 0, it will be 1. So, and can you see that there's a straight line emerging? The green dots. And I'm going to put the pink one in, which is 9. So at 0, we'll go 9. So we'll go there. Next one is at 1. We go to 2. So there. Can you see it's just going to keep going? So this line will just keep going. And now I'm going to do a straight line here. I can confidently say that this line goes like that. And I'm going to try to draw it better than that. It keeps trying to mess it up. So I'm going to try to do it freehand, which is always a bit dangerous with me. There we go. That's not bad. Use a ruler if you have to. Now I'm going to do the next one for the pink one. So at 1, it will be 6. So we'll go 1, 2, 3, 4, 5, 6. Yep. At 2, it will be 3. So at 2, it will be 3. That's interesting. And then at 3, it will be 0. So at 3, it will be 0. So this is my pink one. And I can join these crosses and get a line happening as well. All right. So that top one, I needed to draw it there. So the question is, what is the point of intersection? Well, I can see that it occurs right here. And what's that point? Well, that point looks like it is 2, 3, okay? And you look on the table of values, that's the case here. Can you see that both of these are 3s? So that's how we know. So let's sum this up. Therefore, point of intersection is 2, 3. Therefore, x equals 2 and y equals 3. And we're happy about that. Peace out.